record. Okay, so 4.1 was talking about discrete distributions. We will look at continuous distributions when we come back in January, okay? So discrete versus continuous. Remember, discrete is like a solid number. You can count it, okay? Versus continuous, you have like a range, okay? So you have like half of a tank of gas, okay? You can't have half of a person. So number 3, let X represent the speed of a space shuttle. Would that be discrete or continuous? Speed of a space shuttle. Continuous. Okay. Because you could be going like half a mile, or like you could be going, they would not be going half a mile an hour, but let's say like 5,100.5 miles per hour or something. Okay. That half makes it continuous. Okay, what about let X represent the number of calves born on a farm in 1 year? Discrete. Hopefully there's no half of a calf. That would be sad. Okay. All right, then we talk about discrete probability distribution. So we're gonna be making tables similar to our frequency distributions. These are actually easier in my opinion. There's less nonsense on the table. Okay, but we have 2 key things. Each of your probabilities, just like normal, have to be between 0 and 1. And then since we're looking at a total group and we're finding the probability of each section, the sum of those all have to be 1. Okay. So then we looked at how to make a frequency distribution. Okay, the difficult part that we can have with these is that when you do find that sum, if you rounded, it might be off slightly. Okay. So be careful when you're rounding. Make sure you round everything to the same. You might have to go to 5 decimal places. Okay, so make sure on your homework you're reading what it says to do. If you make a mistake, that's going to be where it's at. Okay. All right, so then we looked at determining, are these probability distributions? So looking at our first one, are our probabilities all between 0 and 1? Looking at all the P of X's, are they all between 0 and 1? Yeah. Okay, do they add up to be 1? No, what do they add up to be? Anybody know? I don't. I just know that it doesn't.
1.07.
1.07. Thank you. Okay, so that's the reason why it's not a probability distribution. What about number 2? Number 2 is a little easier. Is it a probability distribution? No, why not? Because there's a -1. Because the probability of 4 equals -1, which is not possible. Which is not possible. Okay. And then we have our normal formulas for mean, variance, and standard deviation. Okay, these are the same ones we use with frequency distributions. We just don't have to deal with the midpoint. Okay, our X value is just the X value it gives us for the probability. Okay. So we found the mean, X times P of X, and then added those all up. Make sure you round to 1 decimal place more than your original data. And then I gave you the formulas for variance and standard deviation. Those are on your formula sheet. But I said we would review it. Okay, so this is the one where we made our table. Okay, so you can do this by hand, and that's perfectly fine. So if you were to do it by hand, and we're not going to completely finish it, I'm just going to show it to you. We have our X values. We have our probabilities that we found on the previous example. Okay, we found our mean to be 2.9. but then unrounded, just remember that's what we need to be using for our calculations, was 2.94. So when we make our table, our next column would be x minus mu squared. And then we would do x minus mu squared times the probability. Okay. So just so we know what we're talking about, if we do that first row, our x value is 1 minus the mean 2.94 and square it. And you get approximately 3.7636. And then you're going to take that number, 3.7636, and you're going to multiply it. Oops. It's not too black, so we can actually see this, by the 0.16. Which gives you 0.602176. And you would continue that for all 5 rows. Okay, this one by hand isn't bad because there are only 5 rows. The more rows it has, the more difficult it becomes. Okay, what was the thing that I showed you guys a few weeks ago of another way we can find standard deviation? You may remember? Like eyes got really big and you got really kind of mad at me that I didn't show it to you earlier. Google Sheets. Okay, so let's review that. And I can have a cursor, that helps. Maybe. All right, so let's zoom that in. Okay, so I went ahead and copied over that probability distribution table, x and p of x. And then remember our mean. So we have x minus 2.94 squared. Okay, when we typed in our equations, what did we always have to type in first?
Equal.
Equal, okay? So if we type in equal, and then our parenthesis, click on your x value, minus the 2.94 squared, and then we drag that down. Okay. And then we're going to take that previous column and then we're going to multiply by the probability of x. Oops. Okay, so we're going to do equals, and then you're just going to multiply column C times column B. And then drag it down. Okay, after you find those, we just need to find the sum. So this one is slightly different than what we've done previously. We don't have to divide by anything. Okay. So we get 1.6164. We don't need to divide because we're talking about probability already. So what did we just find? What is that called? Variance. So our variance is what? How would you round that? 1.6. And then how do we find our standard deviation? Square root. And what do we square root? Right, that original. So what would the standard deviation be? How would you round that? 1 point, what was it? 3. Sorry, just can't hear you guys. I'm perfectly fine with you using the technology that you have available to you. Okay. Second semester, I'll show you guys how to do it in the graphing calculator when we have just single data. Okay. Questions on the Google Sheets? Offsite, you guys good? All right. Okay, I think we have one more example, so I'm going to switch back over to my iPad. All right. Okay, so then we talk about expected value. Okay, expected value is very similar to the mean of a probability distribution. Expected value is used when we're finding the chances of winning like a raffle or the lottery, anything like that, okay? We're talking about money here, so we can be negative. Expected value is the only type of mean, variance, standard deviation, any calculation we're gonna be looking at where we can't have a negative value, okay? Negative means that we've lost. More than likely, we're going to lose. The smaller the negative number, the more likely you're going to lose. If it's a positive number, you're more likely to win. So you should be playing that raffle or that game. If it's 0, what did I say it was?
Break even.
Break even, okay? You're gonna have an equal chance of winning. You're gonna break even, win or lose, okay? Okay, so let's look at this example. A charity organization is selling $5 raffle tickets as part of a fundraising program. The first prize is a trip to Mexico valued at $3,450, and the second prize is a weekend spa package valued at $750. The remaining 20 prizes are $25 gas cards. Find the number of tickets sold, the number of tickets sold is 6,000. So if we make our table, remember, X represents the gain. And then we're going to find our probability. All right. So first prize we have is a trip to Mexico, $3,450. How much are you actually gaining if you win that? $3,445. Because yes, you won $3,450 essentially, but how much did you have to pay to win that? The $5 for the ticket. Okay. So how many people are going to win that trip to Mexico? 1 out of how many people total? 6,000. And leave it as a fraction for now. It's going to make the calculations part easier. Okay. All right, our second prize is a spa package for $750. So how much are we actually gaining? 745. How many people win that? 1 out of 6,000. And then we have 20 $25 gas cards. So the $25 gas card is actually a gain of how much? 20. And what's the probability of winning that? 20 out of the 6,000, because there are 20 gas cards. Okay, if you add those numerators to get together, what do you get? Numerators? 1 plus 1 plus 20? 22. Okay, we know that the sum of all of our probabilities should add up to be what? Anybody out there? They should all add up to be, I'm telling you the answer. 1. So does 22 divided by 6,000 equal 1? No, it would need to be what? 6,000 over 6,000? So we have one more column. We need to figure out what the gain was for the other 5,978 people. -5. Because that are all the people that lost. They lost their $5 and they have to be included to find the expected value of the game. Okay, that is probably the trickiest part. There's 2 things. Making sure that you subtract the amount of the ticket and then that you include the lost. Okay, so now we're going to find the product of those two rows. So x times p of x. Easiest thing, multiply your numerator. So our first one would be 3,445 over 6,000. So one time I'm going to say stick with a fraction, don't make it a decimal. Okay, then we have 745 over 6,000. What's 20 times 20? 400 over 6,000. And then lastly, take negative 5 times 5,978. Negative 29,890 over the 6,000. Okay. Expected value is the same thing as your mean. So we're going to find the sum of our x times p of x. So that last row we just found. So we have common denominators. So just add up your numerators. So first off, it's going to be a positive or a negative? Negative, because that negative 29,000. So we get negative 25,300. And if we divide by 6,000, and then how many places did I say we should round to? 2, because we're talking about money. So we have a negative $4.22. Negative $4.22. Okay. Questions?
There can be a short